Well, obviously, thank you for our attendance here. I appreciate everybody coming out today to hear about E3. John Muir once said, "When one tugs at a single thing in nature, he finds it attached to the rest of the world." What do we need in society? Water. We are applied science. We are best management practices. Our technology, we declare as being the best in the state of California. What happens in California sets the standards in the production for the rest of the world to follow. What we want is three things: fuel, food, and health. This event is being run off solar. What we have is a solution that enables those that are in the carbon-based economy to identify with us and brand with us an opportunity to tug at that one thing, which we all need, is water. So in understanding that we're here identifying solutions, we want California, we want the world to know that what we demonstrate here in Martinez is for a purpose. We want to joint venture with the city of Martinez to create a platform of opportunity. As we know, here in the state of California, there is a lack of water. The current solutions are fixed permanent plants, $600 million to $1 billion in cost. What we have is an opportunity to create job skills and bring this technology together where a city can champion, we call it going heroic, champion the solutions so that there will be less pollution. What we're going to demonstrate today is effectively taking hydrocarbons out of the mixture of the water, Bay Area water, brackish water, where there is an abundance. Instead of going down into the groundwater aquifers, which are declining, as the population goes up, the groundwater goes down. So the technology that we can demonstrate is not a fixed-based operation. It can become for cities like Las Vegas, but for here in the state of California, it makes sense to do a mobile operation to scale this technology, to give it means and make it efficient for the state so you can move it and operate it and joint venture with other cities that are in need. So when there's a time of need, there needs to be a model of a city that can take this mobile resource and joint venture, donate, or sell the water at a discount for service of operation. Understanding that is the very key thing that you need to understand here. Because what will happen, it will model and it will shape the rest of the world. Moving things like this to the next level means you're going to have a team. The E3 team consists of the best. Today, Michael Green's going to be talking. He's our Chief Technology Officer. Michael has an aquatic engineering doctorate. You can take technology and you can enhance the water to give abundance of fuel production, abundance of food production, and abundance of health by changing and realigning the engineering of water. That's what Michael Green does. Reinhold Ziegler, he's been demonstrating the best of the best. The #1 solar project in the country of Mexico, okay, where solar is king, he built a cement factory that has to stay at 65 degrees. There's nowhere else in the world. He did that. That's the #1 solar project. Michael DeGrasso, he's our Chief Marketing Officer, a policy creator. He's worked in the agency world. I want you to understand that what we demonstrate here in California can become adopted. They become modeled. I mean, obviously we have the VIPs here and the politicians that have come, and I really appreciate everybody coming here. We will demonstrate these technologies, but I also want you to feel free to ask questions and understand that we're here and we will come back. Mark Scott is going to get up here. His background is UPS, developing the largest expansion of UPS to China, to Russia, Europe. There's a skill set that you got to have here, and I'm trying to identify that we are a skilled group of individuals. Thank you for attending.
All right, I get the fun stuff to do. I get to tell you about what we're going to do today and what you're going to see. And so here we are today, standing before you, talking about the launch of several different technologies. Over the next 90 days, we'll be completing our fabrication agreements so that we can actually begin full line production. What you're going to see today is based on a technology which is called ECoS3 with Pulse. And we're actually going to demonstrate for you what we did yesterday, taking water out of the Martinez Bay. And actually, we're going to get to drink it if you are so inclined. Now, I already had some of that, and it's actually quite good. What we're actually going to do, though, is we're going to show you how the technology works, how we operationalize the cleaning of water, the remediation of water, and in particular, how we deal with all of the various chemicals and biologics that are embedded in water. And water, of course, is being used today for industrial agricultural processes. As we go down to California's formerly high-producing agriculture area, the wells are becoming more salty. That is, the saline is increasing. We're finding boron actually coming into the grapes and causing impact on the wine industry. If we don't begin to solve these problems now, not in 10 years, not in 5 years, not on the basis of economic and environmental studies, but on the basis of a solution which is fully mobilized, which has a low profile, no more than the trailer you see to your left, where we are able to move it where the needs occur and be able to process not only groundwater, but runoff, as well as other water that's being used. Our ECoS3 system solves that problem. And it does so between 600 and 1,000 gallons per minute. The average desalination plant, which is a fixed base of operation, which takes between 5 to 10 years to permit, is at least $250 million. The fact of the matter is, we don't have 10 years to wait. We need to solve people's problems today, not only in terms of producing water for irrigation and potability, but also in terms of producing water and reusing water in industrial processes, in the oil and gas industry, in mine tailings, in geothermal. ECoS3 will solve that problem. The notion is, of course, providing a mobile solution, not a fixed base of operations, to take out much of the environmental impact of the trucking operations that you see moving water back and forth today, by being able to position our units where the water reclamation is required, and then to deliver that water for its use in agriculture or drinking. And to be able to do this on a worldwide basis. We're already in negotiations on a joint venture with a group out of South Africa, MOGS, Mining Oil and Gas Services Company, to distribute this technology throughout the continent. The fundamental problems there, even in the mines, where gold is being mined and precious metals are being mined, they're being inundated with groundwater that's mixing with the disposal water, endangering the very fabric of the mining industry. In Australia, we're launching also in the New South Wales water treatment, where there is other minor amounts of radioactive material coming into the water stream that we can actually treat. In addition, we are also going to be announcing our new process of E3 Irrigate. This is a system which has been designed, patent pending, which actually allows us to put an underground solution that reclaims water, not only from runoff and rainwater that occurs naturally, but from the irrigation that oftentimes is lost because it doesn't penetrate deep into the ground. The system itself is a simplified solution that reclaims that water, reprocesses, and allows potential impact of 60% increase in use of that water for subsequent irrigation. In addition, we're dealing with one last major announcement today, which is our residential commercial gray water. It's E3 RCGW. Now, we'll come up with some fancy names later, I assure you. But the E3 RCGW essentially takes water, gray water from the house, and reprocesses that water using a combination of our systems here in a smaller commercial unit, and by creating a closed loop. So all the water you're using to wash dishes, clean your house, obviously take showers in, gets remediated and brought back into the house. Now, today many people look at fresh water as a disposable resource. Folks, we have all the water we're ever going to have on this planet. And the problem I have is, at the end of the day, we don't look at water as a precious resource in many of our daily applications. We like a long shower. We want to make sure we flush our toilets. But the fact of the matter is, we're using fresh, potable water to do so. We have a solution. E3's RCGW solution will be commercialized over the next 90 days, and we'll begin selling that into the first of the year. We've acquired technologies around the world. We've identified key inventors that we partner with, and we've established corporations under the head of E3 Inc., to design and to operate these solutions. We're not simply selling product, we're selling an output, we're selling a service. And all of that is being incorporated not only in terms of what we do as a business, which not only includes our water remediation and reclamation business, but our biodegradable lubricants and technologies, our hydrogen-powered energy systems. We have partners such as ECoLo Blue here. You have water made right from air in this cooler. Try it out today. We're working with ECoLo Blue to build a distribution model that integrates, more importantly, the ability to use solar power from our friends at the Soul Man, as we like to say, which actually uses Soul Industries, which provides all the power we're using for this press conference right now, including the lighting, strictly from solar in a mobilized version. One of the things you'll hear me talk a lot about and what you're going to see today is the mobilized nature of this technology. We can no longer afford to fix base operations. We know that climate's changing over time. Demographics are changing over time. The ability to move and modify our technology in the environment and in the community is critical. And I will also tell you, everything we're doing is made in America. Now, that's not to say that I'm an uber nationalist, but I believe at the end of the day, Americans designing and innovating, building with Americans and serving Americans is a very good idea for an economy that continually is being challenged. And to do so in a way that is both environmentally friendly and economically beneficial. And if we can begin to encourage people to make these incremental changes over time, as I like to say when I was opening up China, selling 1.3 pieces of bubble gum every day is a very good business. If we can encourage people to use these technologies at a cost basis that is not on the acquisition of a piece of equipment, but on the output of the use per barrel, per gallon, per kilowatt, we change the game, folks. And that's the vision for E3. So what you're going to see today, first of all, I encourage you to take a look at one of the units that we've used in an earlier version, Generation 1. You can go in the front or the back here. I should say don't walk across the pumps because you might tear your clothing. I don't want anybody to get hurt. But we actually have treated over 400,000 gallons of contaminated chlorine water with high particulate matter, what we call suspended solids and dissolved solids, at a major chemical spill that took place in Bakersfield, California. Inside, you're going to see our next generation solution, where we're taking the bay water, running it through the process, and then serving it out the back end to you. And we're going to challenge you, we're going to challenge some of you who are bold enough to do so, to tell me which one is the fine mineral water that is provided from Martinez, California, versus what we've just given you from the bay. So I invite you at this point to, one, come in and observe what we're doing inside. We very much appreciate your participation. Thank you. And here's to some fresh water.
Hi, how you doing? Good. Good. Hey, Wayne. Good to see you.
We have bags with press kits for you, also USB drives and caps. Please feel free to take one.
Good morning, everybody. Thank you for coming. I want to introduce myself. My name is Michael Dograsso. I am the Chief Marketing Officer for E3. And I also have the luxury of working with Mike from the Research and Development and Engineering Liaison. And this is Michael Green. Michael is our Chief Technology Officer. And then in the back is Mike Lockmore. And Mike work together as part of running this research and development facility. We went and collected over the last day water from the Bay of Martinez over here. Now, what's in that water? There's lots of ships in it. It has a opacity to it, which is called total dissolved solids. The ships that are in the water have bilge tanks of which they evacuate. That goes into the water. So we have hydrocarbons, diesels, so on and so forth. Okay, that's what's in those barrels or those totes. So what we've done is we're going to show you a system, and we're going to show you our processing of the equivalent of what's in that tote. What's in that tote is water that has color to it and water that has oil in it. Okay, so that's representational of the coffee. Coffee has color in it, it stains your clothes, and coffee has oil on the top. And what we're going to do is sequence this, and Mike's going to give the demonstration through our bench technology, okay, best filtering system that you can get out in the marketplace right now. We'll run the coffee through, followed by a bench model of what you're going to see with the commercial version of our technology. It's very difficult to process water at a commercial level that's economically feasible. So I'll turn this over to Mike, and thank you very much. Thank you, Mike.
So, as Mike talked about, coffee represents pretty much everything that we see around us insofar as the San Francisco Bay. What you'll find is coffee is one of the hardest substances to get out of solution. Coffee, you can let it set overnight, you can make a cup. The next morning, the coffee is still brown. So what we're going to do is we're going to do 2 filtration processes first. I'm going to mix up a beaker of coffee, and we'll put it in these jugs. I'm going to process one through a very common home water filtration system, and then we'll also process through ours simultaneously. So let me get this going. Okay, so I'm going to put a teaspoon of coffee in the beaker. Okay, and then we'll put water in there. Okay, just go ahead and pour that, Mike, right into the jug.
Okay. So now if you look very closely, oils are on the surface, solution, pigmentation is in solution.
Okay, so through the home tabletop filtration, which is a very, very good quality water filter, commonly used everywhere, you'll be able to see the filtering effects that it has on coffee. So that's going to take a few minutes to go through. So while this is filtering through, I'm going to go over to our technology, the E3 technology, and pour this in here.
We talk about electrocoagulation, or running electricity through water, disassociating the hydrogen and oxygen, and then flocculating water.
So as Mike says, what we're doing is we're working at the molecular level to disassociate the contaminants in the coffee or in the water. It could be industrial wastewater, it can be oil fracked, produced water, it can be water of any nature. Even the bay water that we're going to process, we're going to use the same scientific principles to do what we're doing. So right now we're applying electrical current to the water, and we're using a very special mixed metal oxide anode and cathode. What we don't want to do is add contaminants back into the water that we would have to later remove. As you watch this, if you can see it, it's starting to get a foam froth on the surface. This is actually lifting the contaminants, or the coffee in this case, out of solution. The beginning water was just simply contra-costa tap water. So what our goal here is, and what we want to achieve, is to get the water back to the condition that we started, the Contra Costa tap water. Now, our technology does a number of different things. One of the things in wastewater is the contaminants, obviously, but also the bacteria, the pathogens, the things that cause sickness and disease. Our process actually disinfects the water of the pathogens, so that the water is actually drinkable in most cases, depending on the starting matrix of the water, once we're finished. So we're just about there. You can see that this froth is increasing. We're splitting water. We're splitting, like Mike said, water from H2O into hydrogen and oxygen, the elements that create the molecular compound of water. There's a little bit of a chlorine smell, but that's the salinity actually in the tap water. It's not 100% salt-free. So this is just probably about ready to go. Grab an extension hose here, get this set up. Start the pump. Bleed the air out of this. So what we're running through is a series of filter media, okay? And each media is designed to remove a certain contaminant out of the water. Now, in the case of tap water and the coffee, it's really not going to have an effect. But let's say, for example, that you had chromium-6, a very toxic metal salt, or let's say arsenic or cyanide, radiation. You're going to be dependent upon medias to actually absorb that out of solution. And so what we have is we have alumina. Alumina is an absorbent. Alumina is one of the primary elements of aluminum. So the water will first flow through the alumina. From there, it'll go into kinetic degradation flux, or what we call KDF. There's two different grades of KDF. And then we'll go into activated carbon. And the activated carbon is basically our polishing process. Activated carbon will absorb the chlorine, the fluorides, things like that out of solution.
So one thing I want to mention while Mike's turning on the pipe or on the pump is that we're removing suspended metals, suspended solids out of solution using filtration. When we run water through our electrocoagulation system, what we do is we knock down almost 100% of the viruses and bacteria. They're killed.
See by comparison what our technology is capable of doing as far as getting coffee out of solution. You can see through the bit of what happens, and then through our. So actually, we start out at lab scale. Basically, is what we started with to develop our technology and to be able to build a scalable technology, such as Mark talked about earlier, in his talk, where we want to take this technology from the lab scale to potentially 600 to 1,000 gallons per minute. And so in doing that, we can actually walk around and see the scaled version that Mark was speaking of. It's basically, we started here, we developed, we perfected, we tweaked, blah, 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 and now we'll move over here. This system here is designed to be expandable. We can build this system a mile long if you wish. Basically, the feed water comes in, fills up the first tank, and goes to the same process that we did over on the lab scale with our electrolysis process. The water then transitions through the production chamber in the center into the second tank. And while that's going on, we have a fully automated computer system, or what we call a PLC, that operates and controls the levels in the tank, and also the collection of the contaminants that we pull off the surface.
So what Mike was saying, you can see the coloration differential between this tank and this tank. And it's continuing, you'll see a block being on the surface with water. This breaks block off in collections. So if that flocculant happened to be oil, hydrocarbons, or anything that was recoverable from the solution, we can literally recycle it through each of the collection tanks. Okay? So in the oil industry, fracking industry, we're able to take hydrocarbons out of solution and recover it. Okay? For secondary processing or turning it into any type of fuel, biofuel.
You can hear these pumps cycling in and out, and that's to do with the level. Again, it's a fully automated machine. This machine can be in New Mexico. We can operate it right here from our office.
We have two power supplies. Each power supply is unique to each set of cathodes and anodes. Okay, and when I talk about cathode and anode, I talk about plus minus, just like the seal of battery. So when frequencies are put through and water is subjected to those frequencies, that's DC current. This goes into an input device through wiring on the back and creates an electrical stimulation of the water. That electrical stimulation disassociates the water molecules. The plus of it is an emitter of ions, the minus of it, which is the lunar collector. And then what happens is contaminant rises to the surface, and from the surface then we reconstitute the water by reassociating the hydrogen and oxygen. And that's how you can release contaminants to the surface and then reconstitute water back.
Okay, so this is the finished product coming through here. Good water? No salt. Okay. Bay Area. I'm still here. Oh, my.
Need more cops.
Really, this is probably very water. Right off in here, right off the coast from the bay.
Everything that's in that bay water has been taken out. And more importantly, we polish the water through the last filtering process. That's what makes the water drinkable. Because up to that point, while we eliminate all the material that's problematic, you still want to have a membrane to roughly 2 or 3 microns to complete the water treatment. And then also we pulse the water. In fact, now you have better taste because it's not just distilled water anymore.